All right, let's see if we can figure this one out. So we have a shape like a wedge of cheese. And I have no idea where these people get their cheese. Because to me, a wedge of cheese has a circular end, right?
Yeah.
This
like
has
wheel
a-
that you
Like
cut.
you take a wheel and then you cut.
This is a cartoon cheese.
This is not that. Yeah, maybe this is like mousetrap cheese from cartoons.
Maybe it's in universe where circles don't
Okay,
exist.
so they have a base of the XY plane, right?
Oh man, I think put
Okay.
cheese in that.
XY plane.
Big old block. Of
There's
cheese.
your base, right? Then it has sides. Y is X. What does that look like?
Straight line from the origin.
Okay. So there's Y is X. So apparently that's one of the sides, right? And that's going to be swept vertically in Z's, right? Okay. And then it's got another side that's X plus Y is 1.
So
That
you,
one.
you could do that as y equals 1 minus x.
Okay. So that's Y is 1 minus X. So that looks like go up 1, slope of -1. Runs through here. I might wonder where that intersection is. That's probably going to be important, right? Maybe.
Yeah.
Okay, and then that's swept up and down, right? Donald just noticed where this is.
She's looking at me all weird.
Where is this?
Is that a half and a half?
A half, and 0, right? You guys see that? Okay. So I've got vertical sides there, and then I've got X plus Y plus Z is 2. That's a plane, right? And the normal for that plane is,
Like a triangle wedge.
yeah, I think so. They didn't tell me the y-axis binds anything. They said the x-axis binds stuff. So what I assume they mean by that is the xz plane is one of the bounds, but I could be wrong. You guys see any more information that would help me?
Well, we should have the right amount of intersections.
Well, okay, so those are the sides. It says that the x
So-
plus y plus is the top. Is the
Yeah,
top
so this
plane.
is the top. The bottom is the xy plane, right? Okay. And then I'm just not sure whether I'm talking about this region or that one. You guys see that?
Yeah. The
So they say the x-axis, right? Which I think means that they're looking at this stretched up vertically. So I think they're talking about this piece here. Let's assume they're talking about that piece there. Cool.
Okay.
So I'm going to need a triple integral, right?
Yeah.
I'm going to need some order. And then what am I going to be integrating?
The 4 times the distance from the x1.
Okay, so there's definitely a 4. What's the distance from the xy plane?
Can you pull out the 4 completely?
Yeah, we could pull a 4 all the way up front.
The
I'm going to
dis-
leave it in there for
the
now. But,
distance from the xy plane when we got
so how far is a point xyz from the xy plane? Like if the xy plane is the ground, here's a random point. How far is this from that?
2 minus
x squared. Oh wait, square root.
Minus your x and y.
Yeah, that's
Square root.
Too complicated. Yeah, it's just the z value, right?
Oh. Okay.
If I'm asking how high it, right? How far is something from the ground? I'm just asking how high it is.
So
See that?
Z would be
So the distance from the xy plane is just z.
Oh, okay.
And then what's your order of integration?
Guess we're gonna do dz. I'm guessing.
Probably do dz first, right? So let's sort out the bounds on dz. Where do the z's range from?
0 to 2?
They go from 0 to
To
what's the top of your slice of cheese?
that.
2 minus
2
x
minus
minus
x
y.
minus y.
This thing, right? So I need 2 minus x minus y in there. Right, because I'm wondering what's z at that top. So maybe if I threw some thoughts in here, right? I'd really be thinking the z's go from z is 0 to z is that stuff, right? 2 minus x minus y.
And now the next one we could be either. We can choose.
Good, yeah, I want to do the x first because the x will go between these two things, right?
Yeah.
Oh, okay.
Okay, see that?
Okay.
Right, so I already integrated out the z's so I could smash this picture into the two-dimensional version and get these two lines, right? So the x's, they want to go from this line to that line, right?
Yeah.
So what's the first line? What's the line on the left?
X.
So I want to arrange the x's from, so doing dx, I want to arrange the x's from x.
So it'd be y.
Is that?
Y.
And
Why
then-
can't I put an x there? How about that?
Because we want that outside. Well, why can't you put an x?
Yeah,
It's
like
already
if I
wor-
put an x here, how would I know I was crazy?
Because we're already integrating x.
Yeah, because I'm integrating the x's out. This would put them back in, right? That would be a problem. So I want to go from y to
X.
perfect.
1 minus
X plus y is 1, right? Is where I want to go. And I need to rearrange it so I can solve for x. So I should get a 1 minus y there.
So why is that y and not like 0 or?
Right here I'm thinking x and x. That's, I want to go from this line here, right? That's y equals x. And I want to go to this line here, which is x plus y is 1.
Okay.
So I want to know where do the x's range? Well, the x's range from y to what's the x when I get to the end? X is 1 minus y. See that?
Yeah.
Okay. And then where do the, what's left?
Just dy.
Which is 0 to 1/2.
Good. I want to do y's from 0 to 1/2. Right? Because when I look at this picture, this is the point 1/2, 1/2. And this is y is 0, right? So after I smash this way, I want to do this bit and the y's, and those go from 0 to 1/2.
So it's 1/2 because. It's y.
Because you want to.
So it's 1/2 because the y value on this point is 1/2.
How'd you get the 1/2?
I set this thing equal to that thing,
Okay.
kind of.
Yeah.
And by kind of, I mean I made a substitution for one of the variables. Right, that was to find this intersection. Cool?
Could you do it dz, dy, dx?
Sure, you could. If you do dz, dy, dx, then your y's are gonna, in part of it, they're gonna go from 0 to x, and in the other part, they're gonna go from 0 to 1 minus x. So I'd have to split it into two integrals. So yeah, you totally can, but you'll end up with two pieces. Do you want me to write them down?
Sure.
Okay, so I would say this is the same thing, right? As if we integrated 4z dz dy dx plus the integral of 4z dz dy dx. And now I need to sort out the bits, right? So the z's are still going to be the same. Those are going to go from 0 to 2 minus x minus y in both. And then the y's on the first bit, right? I'm cutting this and I'm looking at the left half. So they're going to go from 0 to x. And then the x's are going to range in that first half between we need to make that picture a bit bigger. Okay, so I got my x-axis and my y-axis. This is the line, y is x. This is the line, x plus y. Oops. This is the line, y is x. And this is the line, y plus x is 1, right? So if I'm just talking about the left half, where do the x's range? They go from 0 to a half. And on the other one, where do the y's range? Right, in here.
1 minus x.
Yeah, the y's go from 0 to 1 minus x. And the x's on that one go from,
1/2 to 1.
perfect, 1/2 to 1. Cool.
Got it.
I would definitely recommend ordering your variables in a way that everything's going to fall out nice and easy. If you play with these guys, it's a good way to get confused.
So it's 4 times z, not like 4 times z times x times y. Like, why is it 4 times z?
Because they told me that the density is 4 times the distance from the xy plane.
Okay.
The distance a point is from the xy plane is just how high it is. It's just the z value. That was specified in the problem as this is the density function. And then what I get when I integrate the density function is going to be what?
It's going to be a mass.
Yeah, perfect. It's going to be a total mass. Cool? Questions, things?
Yep.